these are the 1.6 solving other types of equations practice problems, number 8. So in number 8, we have what looks like a polynomial of the quadratic type. So we got c squared plus 5 quantity squared minus 8 times c squared plus 5 minus 48 equals 0. All right, so if I was in high school taking algebra 2 for the first time and I saw this, I would see like a very complicated equation. But as you practice this and as you see more of these, you start to see this as a quadratic. All right, what do I notice? I notice that there's the unknown is c, but c squared plus 5 is still like an unknown quantity, and it appears twice. So like if we substitute out something for c squared plus 5, so maybe let c squared plus 5 equal x, and then plug that back in, it turns into a quadratic that is much more familiar, that you're used to solving by probably factoring. All right, so now we have x squared minus 8x minus 48 equals 0. And we know that x is equal to this. So by substituting, we take a complicated equation and turn it into two simpler equations. And now it's sort of like a system where we're going to solve for x here and then plug that in there and then see what c is. So when I solve for x here, I got to find two numbers that multiply to negative 48 and add to negative 8. So that's going to be negative 12 and 4. Positive 4. So when I set each factor equal to 0 and solve, which is why we factor, because if either factor is equal to 0, it'll satisfy this, because anything times 0 is 0. I get x equals 12 and x equals negative 4. So if we were solving this, we would be done, but we're solving this. And we know that c squared plus 5 is equal to x. So c squared plus 5 could equal 12, or c squared plus 5 could equal negative 4. So when I solve this equation, I get c squared is equal to 7. And then I can take the square root of both sides. And because if you square a negative or a positive, it's going to turn into a positive. This will be positive or negative root 7. So those are two of your solutions. And then if we keep going with the other equation, we subtract 5 and we get negative 9. We take the square root and we get c squared is equal to positive or negative the square root of negative 9. Now we know from learning about complex numbers that the square root of negative 1 is equal to I. So if you have the square root of negative 9, you could break that up as root negative 1 times root 9. Oops. So we can write that as I times 3, or 3I. So we get plus or minus 3I. And those are our four solutions that'll satisfy this. A good rule of thumb that we haven't formally learned about yet, but we will. It's called the fundamental theorem of algebra. The degree of a polynomial equation will tell you the number of solutions, whether they're repeated, whether they're real, whether they're not real. Since if you were to multiply this out, this would be a fourth degree polynomial. Like it'd be c to the fourth plus blah, 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 blah equals 0. It would ultimately, in standard form, be a fourth degree polynomial, which means you would have four solutions. And we have that. Plus or minus root 7, plus or minus 3i. All right? And that's how you do this one. And then just like a quick look at, like a connection to that, if you had something like this, like c cubed minus 8 equals 0, all right, this is going to have three solutions. If you just take the cube root of 8, you're only going to get one of those solutions. Oh, crap, the cube root, not the eighth root. You get c is equal to 2, which is why we want to factor whenever we get a polynomial that we can't solve using like the quadratic formula. So we get that one solution, that's c squared plus 2c plus 4. So we get c is equal to 2. And then the other two solutions we would get by doing the quadratic formula. So we'd get c is also equal to negative 2 plus or minus the square root of root negative 12 over 2. So it would be negative 2 plus or minus 2i root 3 over 2. And you get negative 1 plus or minus I root 3. So there are your other two solutions. Plus or minus I root 3. Sorry, negative 1 plus or minus I root 3 and 2. And the point of me connecting this to this is that this was a third degree polynomial equation. So it means you have three solutions, 1, 2, and 3. There you go. 2 problems for the price of 1.